Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and special edition of This Week in Weather. I'm your host and meteorologist DT from Weather Risk here in Central Virginia. The captain of chaos, the colonel of confusion, the commander of catastrophe. We're going to be talking about this hurricane with the strange name called Isaiah or Isaias or something like that. I can't even pronounce the damn thing. So we're just going to call it the I storm because in fact, when you're dyslexic like I am, I'm not even sure if I spelt the damn thing right. Really, it's a very difficult name when you're dyslexic to spell, let me tell you. Anywho, so let's get right to it. Here's a picture of my smiling face from Richmond, Virginia. You can reach me on the Twitter page, on the Facebook page, and my emails. We're going to start out by taking a look at the current situation here. This is the current shear, and this is a nice map here because it shows a lot of information with it. And with it, you can see the track of the system going right up through here. It's a little complicated map here, so it's right about here. And the important point here is all this red stuff that you're seeing in this area in here. This is all the red stuff. You see all this red stuff in here. That's all shear. And a lot of winds there, 30, 40 knots, and that's not good. Part of that shear extends up into the forward path of it. So that's one of the reasons why it's having trouble strengthening, even as it moves away from Hispaniola into the Bahamas. And the water temperatures are pretty warm. So, it does look like some of the shear is going to break down, but that's one of the reasons why it's having problems. It is a late Friday infrared here. You can see it's blowing up very nicely. It's a nice looking storm, and the clouds are massive. They're finally wrapping around the full center of it, so that's a good sign. And we can see in the visible satellite picture again a little bit of shear here on the western side of it. Looking most of the cloud is on the eastern cloud mass is on the eastern side of it. But it does look like it is beginning to intensify here a little bit. And if you look at the latest surface plot from Tropical Tidbits, you can see where it is there in the southern Bahamas. And that seems to be a pretty good approximation of where it is based on the satellite picture. Now, the latest information just showed that the pressure is actually down to about 991 millibars. So it is slowly but steadily strengthening here. And that's a dangerous sign, of course, as it approaches the Bahamas and then eastern Florida and potentially the southeast U.S. coast. If you look at this shear trend here, we can see, again, for those of you that are not familiar with this, the orange, now this is the shear here. So over on the right-hand side, this is the shear. You see that right here? So this is where the shear gets very strong. So we can see there's some shear here, and then also a little bit in the yellow right in front of the system, and then more shear up this way. But notice there's a gap right in here where there's not much going on. And this gap, let me point out to you again so you can see it, where the shear is actually at approach to the southeast U.S. coast, the shear is actually there pretty reduced. So it's possible when it moves in the Gulf Stream in this direction here, that's when it really could begin to intensify a little bit before landfall. So that's something to keep in mind. And if we look at it, we zoom in here a little bit, we can see again with more detail. And again, the shear areas, just to point them out, you can see them. Let me change this here. You can see these shear areas very nicely, right in here, and again right in here. So there's shear around it. Right now it's kind of in between, so that's one of the reasons why it's intensifying a little bit. But there is shear ahead of it. But again, up to the north, there isn't. So it's going to go through a couple of different cycles here. Now, the main point here is that we've seen a shift here in all the models. I talked about this in the Facebook page and before. This is the Gfs Ensemble, the European Ensemble, both valid here Monday night. And what's important to notice here is that both models now have a pretty strong dome, which you can see in the Eastern Atlantic Ocean. This is called the Western Atlantic Ridge, also known as the Bermuda High. And here's the big trough. You can see this trough. Now, this is very unusual. Normally, you don't see a trough this massive for early August. This thing actually plunges all the way down from central Canada. It goes like this. That's a pretty big trough. So what's happened is that the hurricane can't go into the ridge, can't do that, and it's not going to go into the trough, so it's got to take this track right along the coast. And, that's what the models have been showing here for, especially the European, for quite a while. Now, this is a shift in the hurricane models. So here we can see the early Friday morning ones versus the 18Z runs. And you can see a clear shift to the west. You see how all the hurricane models are now west of Hatteras? and into southeast Virginia. They'll also, again, if you look at the image on the left here, notice that most of the hurricane models early this Friday morning were not in Florida. Now a lot of them are, or right on the coast. So, and obviously they're making landfall by Wilmington to Myrtle Beach, where before, from the early this morning, it was generally east of Myrtle Beach and making landfall more like Morehead City. So obviously this has significant implications, this slight shift. If we look at the hurricane intensity tracks here at 18Z, you can see, it weakens. As it comes further north, it makes landfall 72, 84 hours. It falls apart, hits the land, and weakens pretty steadily. This here is the British ensemble on the left, and then this is the 12Z run, and then the European. And again, look at the big shift. If you can compare this to what we saw yesterday, the day before, this is now, there's Hatteras. So you can see a lot of right along the east coast of Florida, or just offshore, and then making landfall between Myrtle Beach and Morehead City. Not here, but further to the west. Now that means that the core could get closer to Richmond and pass west, or in Raleigh, North Carolina for that matter, and then pass west of Hatteras, west of Elizabeth City, and then west of even Norfolk, and then up into Salisbury and the lower Maryland Eastern Shore. And you can see that here on the European as well. Again, look, there's Hatteras, well to the west of Hatteras. And look how many of these lines go across eastern Florida. So obviously that's important because, if it does make landfall in eastern Florida, even if it gets into the bend here, it's going to have a hard time intensifying. So that's kind of important. Now the official hurricane track, from this afternoon, 5 p.m., you can see it's got it actually on the Florida coast and then going into the bend. Now, as long as it goes any further west than this, it probably will not lose too much intensity. But if it comes in, goes up the Florida coast, up into, let's say, Savannah, that's going to rip out the guts of the system. So the other difference, of course, is that, once it makes landfall, let's say it makes landfall at Myrtle Beach, and it goes between Raleigh and Elizabeth City. By the time it gets up into eastern Virginia, this is going to be a lot weaker system, and it's going to fall apart significantly. So that's kind of important where the landfall is. And of course, remember here now, where the coast is oblique. We're dealing with the coast here. Call it my marker, you can see it. This is the coast from Savannah to Hatteras. See that? So where does it make landfall? That's the issue. Where along the coast? And it's at an oblique angle. So that's very, very important to figure that out. Now the Gfs ensembles actually do have it making landfall in central Florida. You can see this is now valid here on Sunday night. And then it's actually inland, off the coast, so east of Savannah. They're making landfall at Myrtle Beach and coming up over Richmond, or over Raleigh and Richmond, between Richmond and Norfolk, that sort of thing. And that's a very viable track given the intensity of these monster dome developing in the West Atlantic Ocean. Let's take a look at the European model. Now this here's the European model for, and again, it's not that the European model is perfect, but it was the first one to pick up on the westward shift, so I think it's kind of important here. Now here is the European model. This is valid as of Tuesday morning at 2 a.m. They're making landfall actually close to Charleston, if this is right, between Charleston and Myrtle Beach. Now, of course, ahead of it, we're going to have a lot of warm air coming in here with the southerly winds driving the humid air up. So you got a barrier line here, and a lot of showers and thunderstorms ahead of the system. But the main system is here. That's where the tropical storm or hurricane is. Now, if that intensity is right, it's probably a tropical storm. Now, this is valid for Tuesday morning. You can see it's inland now, north of Myrtle Beach, closing on in Fayetteville, and driving to the northeast. And you can see it's probably going to pass, if this track is west of Hatteras. And sure enough, here we can see it's over Emporia. And it looks like it's going to pass between Norfolk and Richmond. You can see that pretty close to Raleigh, just to the east of that. Now, that means if you're in the Outer Banks of North Carolina, if this is correct, and you're in the Outer Banks of North Carolina, you're not going to get the worst of this. Now, you'll get some wind, you get some rain, but you're not going to get blasted by hurricane force winds. Not if the thing's making landfall here. The eastern side of it will fall apart. It's only a tropical storm anyway. So you'll get some winds, 50, 55, 60 mile-an-hour gusts maybe, but that's about it. The heaviest rains, if this is correct, is actually going to be over central Virginia and Richmond area, up into the northern neck, middle peninsula, southern Maryland, and into the Salisbury. This whole area in here, that's where it's going to get the worst of it. Now, and of course, the winds, again, if it goes in that far inland, the winds when they get north of Raleigh into Richmond and eastern Virginia, Delmarva, not going to be that great either. So that's kind of significant. And then finally, we can see the system here. Now, this is now Tuesday night, actually early Wednesday morning, 2 a.m. It's in the central Chesapeake Bay. 997. It's still a tropical storm. It's still windy. It's still stormy, and then it pushes up into finally into central New Jersey, close to New York City, early Wednesday morning, August 5. Now here we have the European model showing the maximum wind gusts for the duration of the event, and you can see that the best winds clearly are west of Hatteras, west of Norfolk. You can see that really west of Elizabeth City. Maine, there's a small core here which goes up just to the east of Raleigh, goes to Fayetteville, Raleigh, Emporia, maybe to Petersburg, but definitely interior Eastern Virginia, Middle Peninsula, Northern Neck, into the Chesapeake Bay, and then into the southern Maryland, lower Delaware, and the coastal New Jersey. And the winds, of course, are not much weaker than what the European was showing the other day when it had these ridiculously high winds. But again, 50, 60 mile an hour winds, not out of the question in a small core here. The other thing is, of course, if it does this, what's going to happen is if it does this sort of track goes inland, you could have some significant tornado activity in eastern North Carolina, eastern Virginia, as the system gets ripped apart because of the land friction. That often happens with tropical systems which track on an inland coast. We saw that with Florence. We saw that with other storms. So when they come inland. So that is a concern here if it does take a track further inland. And finally, this here is the 18Z NAM, and I'm not a big fan of the NAM for tropical systems, but it does appear to be pretty close to the European and the hurricane models. Now here, the NAM does keep it off the Florida coast, and obviously that's a possibility. I mean, we don't know if it's going to hit the Florida coast. It might not, so we could see. But you can see here it is, the valid on a Saturday night, and then Sunday afternoon. You can see it's very close to the Florida coast, but offshore, and then probably by just 75 miles, 50 miles east of Savannah, headed for central South Carolina coast, which is similar to what the European model is showing here. So that it makes sense. That's a viable possibility of where the system could be. And of course, if you notice also, as it crosses the Gulf Stream, it is intensifying a little bit. The pressure get down to 975 on the NAM, and that seems reasonable. It's possible when it crosses the Gulf Stream. Now, the big question with the turn is, of course, here the Gfs Ensemble shows a wider turn. The hurricane forecast has a wider turn, and most of the hurricane models do as well, the global models. But if it were to turn a little faster, getting around the ridge here, then maybe it could stay off the Florida coast. So that's obviously the big question. And of course, if it stays off the Florida coast, the chances of it coming up the coast, further up the coast, if it stays off the Florida coast, then the chances of it coming up by Myrtle Beach is higher, which is worse for Southeast Virginia, worse for the Outer Banks of North Carolina, for eastern North Carolina. If it makes landfall in Florida, it's a weaker storm for everybody, and it's probably going to come up the coast further down by Charleston, which means a further track inland, which means less friction but more tornado threat. So those are our different possibilities. This is a short presentation just focusing on the hurricane. This is meteorologist DT from Weather Risk. I'll talk to you soon.